This video is all about a sample problem for calorimetry wherein we're going to discuss when a hot metal is added into a cold water. Now let's proceed with the sample problem. A 40-gram piece of metal was heated to 95 degrees Celsius and then was added into 85 ml of water at 24 degrees Celsius. After mixing, the temperature was determined to be 40 degrees Celsius. So this is our mixing temperature. And the calorimeter constant is at 45 joule per gram degree Celsius. What is the specific heat of the metal? Now let's proceed. We are given with a calorimeter wherein the calorimeter contains a water at 85 ml and the initial temperature is at 24 degrees Celsius. Okay? The mass of the water, if you're going to multiply the volume of water with the density of the water, which is always at 1 gram per ml, this gives us with the mass of the water at 85 grams. The initial temperature of the water, Ti, is at 24 degrees Celsius. The specific heat of the water, it is always at 4.184 joule per gram degree Celsius. And the calorimeter itself has the same initial temperature with the water inside at 24 degrees Celsius. And we are also given with the calorimeter constant. So the constant or heat capacity of the calorimeter itself is at 45 joule degrees Celsius. Afterwards, a hotter metal with a mass of 40 grams and initial temperature of 95 degrees Celsius was added into the water inside. So after mixing, the whole system had a final temperature of 40 degrees Celsius. Okay? TF, which is the mixing temperature or the final temperature is at 40 degrees Celsius. This is also equal to the final temperature of the metal, final temperature of the water, and final temperature of the calorimeter itself, which is again at 40 degrees Celsius. Now let's proceed with the calculation part in solving for the specific heat of the metal or CP metal. Now we have two versions for these solutions of this problem. The first one is the long cut. Okay. So for the long cut solution, we're going to calculate the heat gained by the water, which is QW, is equal to the absolute value of mass of the water multiplied with the specific heat of the water times the change in temperature TF or mixing temperature minus the initial temperature of the water inside the calorimeter. Now let's plug in the values. This gives us the mass of the water at 85 grams multiplied with the specific heat of the water at 4.184 joule per gram degree Celsius times the change in temperature, the mixing temperature at 40 degrees Celsius minus the initial temperature of the water inside the calorimeter at 24 degrees Celsius. This gives us a value of 5,690.24 joules. For the heat gained by the calorimeter, Qcal, okay, this is the variable for the heat gained of the calorimeter. So Qcal now is equal to the specific heat of the calorimeter multiplied with the final temperature minus initial temperature. So let's plug in the values, 45 joule per gram degree Celsius or 45 joule per degree Celsius multiplied with the change in temperature at 40 degrees Celsius. This is the mixing temperature minus the initial temperature of the calorimeter, which is also equal to the initial temperature of the cold water inside the calorimeter at 24 degrees Celsius. Now, this gives us a value of 720 joules. Now, let's calculate the heat capacity of the metal, CP metal. So how are we going to do it? CP metal now is equal to the absolute value of the whole equation, okay, quantity of Qcal plus Qw all over the quantity of mass of the metal multiplied with the following change in temperature as the mixing temperature minus the initial temperature of the metal. Now let's plug in the values. This gives us Cp metal is equal to the absolute value of the whole equation. Okay, 5,690.24 plus 720 joules all over the mass of the metal, 40 grams, times the change in temperature, mixing temperature 40 degrees Celsius minus the initial temperature of the hot metal at 95 degrees Celsius. Again, this is in absolute values. So this gives us an answer of almost 3 joule gram degrees Celsius. Now let's proceed with the shortcut solution. If we're going to calculate the shortcut for this, we're going to consider the following systems at Qcal plus Q metal plus QH2O is equal to 0. So let's expand the following. This gives us Ccal multiplied with the final temperature minus the initial temperature of the calorimeter plus the mass of the metal times the specific heat of the metal multiplied with the change in temperature, mixing temperature minus the initial temperature of the metal plus the mass of the water times the specific heat of the water multiplied with the change in temperature as the mixing temperature or final temperature minus the initial temperature for the water equated to 0. And then to get now Cp metal or the specific heat of the metal, we have to transpose the other side of equation Ccal. So this becomes negative Ccal minus mass of the water multiplied with specific heat of the water all over, or multiplied with the change in temperature Tf minus Ti all over the following quantity as the mass of the metal times the change in temperature for the metal, which is the final temperature minus the initial temperature of the metal. Let's plug in the values. This gives us Cp metal is equal to negative 45 joule per degree Celsius times the change in temperature 40 degrees Celsius minus 24 degrees Celsius minus 85 grams times 4.184 joule per gram degree Celsius times the following quantity as 40 degrees Celsius minus 24 degrees Celsius all over 40 grams of the metal. And the change in temperature for the metal is 40 degrees Celsius minus 95 degrees Celsius. This gives us a final value for the Cp metal, which is the same with the long cut solution at almost 3 joules per gram degree Celsius. Now that ends my presentation for this type of problem wherein we add a hot metal to a cold water.